Hello everyone. Today we are going to start our journey of chapter calculus for the 12th standard. When we are talking about calculus, can you tell me what is the basic? Because calculus portion started in class 11 only, right? So can you tell me what is the definition? What do you mean by the word calculus? Does anyone has any idea? What do we mean when I say the word calculus? I'll take that as a no. So if you let's go back to class 11 because the entire calculus portion I'll start from class 11. Then I'll move to 12. Okay. So when we were starting in class 11, the calculus portion is never started before we do a certain chapter. Before we do sets, then we do relations, then we do functions because I want function. If I don't understand function, we can't do calculus, right? So when we say the word function, okay, we represent f of x, say x square plus 1. It's a function. I give an input, I'm going to give a value of x, and in return, it's going to give me a return value. It's going to give me an output. So if I put x equal to 1, I'll get 2. If I put x equal to 2, in return, I'll get 5. If I put x equal to 3, in return, I'll get 10, and so on, right? So there will be infinite possibilities of putting the values and getting an answer here. Now, this in this particular topic, till functions, we learned about how to find these values. What are the different possibilities of the values of x that are allowed to put here? All the algebraic things, the plus, the minus, the multiplication, the division of function, all the algebraic things, all the algebraic properties we learned till function. Okay. Now, this function, this equation gives us infinite values, right? For example, if the function would have been x plus 1, the points would have been 0, then I get 1. If I put 1, I'll get 1 plus 1, 2. If I put 2, I'll get 2 plus 1, 3. If for these functions, say g of x, I would have put the value 0, 1, then 1, 2, and I would have joined those points graphically, right? So if I would have plotted all the solutions, all the points that are satisfied, that satisfies this particular function, and if I join them, I get 0, 1, I have 1, comma 2, I have 2, comma 3, and all those points. When I join them, the graph that I get is a straight line, right? So I know that it can be elongated as much as I want. It cuts the x-axis at this particular point, right? Minus 1, comma 0. It cuts the y-axis at 0, comma 1. I can find the slope, I can find the angle, and so many things, right? Now, if the function is this f of x, it's not a linear equation. So, do we know what the graph of this equation will look like? If I even plot the points 1, comma 2, 2 comma 5, 3 comma 10, right? 3 comma 10. Then there are so many points. Can I join them using a straight line? No, it's not a linear equation. So it's not a straight line. Do we know what kind of a graph it will be? Since it's square, it may be a parabola. If I give you x power 4, x power 5, logarithm, there are so many functions and equations that we have in our nature. So if I give you any such random functions, right? If I add here e power x, so do I now know the function? If it would have been quadratic, I know that it's a parabola. But now do we know how the graph will look like? Definitely not. Even I do, right? So a function can always be represented majority wise with the help of a graph. Now, do we know how to draw the graph? No. Graph theory is one of the most complicated portion in mathematics. So if I don't know graph, then why is it such a big, why am I making such a big fuss about it? I don't know it. It's okay. Let's move on. Let's learn something new. No, I can't. If you see, you all watch matches, if I'm not wrong. Sometime or the
Yes,
other
yes, ma'am.
deliberately with your own will, or sometimes only because your friends or family is watching. So for me, because my husband watches it, so I have to. So for me, I don't understand that scorecard, right? I don't understand much of the scorecard. Earlier, I did not understand at all. But instead of that table, the data that's written, when they draw this graph, the over graph, and they has written given a ball here, there's a ball here. This means that in this particular over there was a wicket, right? And the graph shows how many runs were scored or run rate or anything else. So I don't understand the table. I could not make out much from the table, but I can make out a little more from this graph. That this over, like for example, this particular over did the best. right? There were two wickets in the first and the third over, right? So a graph usually gives you much more information than a table or a data that's written otherwise. Anything hidden, there's a trend, there's a pattern, there is a repetitive nature. If there is something that can usually visible in a graph, but how will I know it? For example, if I draw the sales graph of a company, I want to invest in the shares of a company and I see that the sales report looks like this. So starts in this particular year, goes to a maximum year, here, then here, then here. So when I see the graph of this company, I realize that it's not a stable company, right? It's not at all a stable company. Sometimes it goes to a huge hit, then it drops down, then again picks up, then again drops down. It's very unsteady. Yes or no? So to invest in such a company, it would take a lot of guts, which I don't have, right? So whenever we are going to do something, whether it's a sales report or a uh, production report, so there are graphs that are presented because that's much more understandable more than the data. Now, if I look at this particular graph, where will the maximum sale be at which point?
Point B.
Point B. Where is the minimum sale around A, C, or E? Right? When do you start going on a declining trend from point B to C? It drops down. Again, from point D to E, it drops down. When are you on a growing path? From A to B or from C to D? I am in a growing path. Yes or no?
Yes, mom. Yes, mom.
Things which I can directly tell from just looking at the graph, right? So that's why graph is extremely important. And there are so many things that a graph gives you, that graphical properties. Where do you get your maximum? Where do you get the minimum? When the values are increasing? When the values are decreasing? When will it take a sudden turn? All these properties are achievable only with the help of a graph. But graph is not our strong. So do we know how to draw a graph? No, I don't. So this problem is what we are standing at. So what is our problem? That we want to understand the graphs of the function, but we are not good with drawing them. So no one is going to draw the graph for us. But there are properties that a graph tells us that we are very keen to know, we are very keen to learn. Here is where the calculus plays a role, right? We have functions, we understand all the algebraic properties, right? We know how to add the function, how to find the value from the function. If I give you a function x cube and you put 3, what will you get in return?
27.
So we know how to put it. Similarly, if I give you two different values, f of 2 plus f of 1, what will be the answer? Function is x cube. What will be f of 2?
8. 8.
What will be f of 1?
1. 1.
1. So if I add them, what will I get?
9.
9. If I subtract them, what will I get?
7.
7. If I multiply, what will I get?
8.
If I divide, what will I get?
8. 8.
8. So we know the algebraic portions. We are good with it, comparatively at least. But we are not good with the graphical. So what will calculus do? It will tell me that, okay, what's your desire? My desire, my objective is to learn the graphical properties. Okay, so what's the problem? I don't know how to draw the graph. So it says, no worries, what are you good at? I'm good at algebra. We are good at algebraic properties. So calculus says it comes like a genie and it tells us that we can understand the graphical properties of a function by avoiding the drawing the graph altogether. So what we will use? We'll use our strength, that is algebraic properties. So in calculus, what is the role of calculus? It helps us to understand the graphical property, the maximum value, the minimum value, the increasing value, the decreasing value, the turning points, all those things. All those things, it helps us to understand. All those things that a graph gives us, that it helps us to understand. But without drawing the graph, and that's such a huge relief. So what will it use? It will use the algebraic property, the additions, the subtractions, and all those things. So what does calculus do? It helps us to understand the graphical properties of a function with the help of algebra, right? So what does calculus help us to do? Calculus helps us to understand The graphical properties of the function. The graphical properties of the function with the help of algebra. With the help of algebra. Now, functions, then we have calculus. There is a bridge in between that you had limits. In class 11, you had a chapter limit. Limit was the bridge. Limit helps us to connect function, the algebraic properties of the function to calculus. Every single formula that we have is derived using limit. You will see right now. I hope you understand the basic limits. You can calculate
Yes,
limit, right?
Yes, ma'am.
Okay. I need a little, very little. So we are going to use limit, which will form as a bridge between the function and the calculus portion. Okay. So in calculus, we have three topics majorly. Continuity, which was there in class 11. What was the role of continuity? A graph is drawn. Suddenly it breaks down and comes here. Okay. At this particular point, suppose this is the year 2020. So a graph was going on a certain increasing curve or a steady curve, and suddenly the sales shoots up. For example, paracetamol. In the times of COVID, suddenly we all were having fever. Whenever we were unwell, there was nothing prescribed initially. The only thing that we could take was paracetamol. So suddenly the sale of paracetamol shooted, right? Everyone, all the countries wanted that, right? So they weren't projecting that, they weren't expecting that. There was nothing that could have been done to predict that. But the sales suddenly shooted in the year, say 2020 or 2021, whichever year it is. So this is a break in the normal steadiness or the normal path of the curve. Why do I want to know? Why do I want to understand that the graph breaks down at a point? The reason being, when you are studying something, for example, if you are studying previous year sample papers in a few months, will you study before 2020 or 2021, before applied maths, will you do those sample papers?
No, ma'am. No, ma'am.
You will only do the sample paper that comes after that, and even not even the first year ones, right? So, how do you know till which year, from which year you want to see the papers? You need to know that breaking point. You need to know when things turn, when things change, and that is what continuity tells us. Where does the function break down? Okay, we don't need it. Second is differentiation or derivative. Differentiation or derivative. Both are same. This is the only chapter that started in class 11 and will be carried forward in 12, right to where we stopped. It was stopped in class 11. From there itself, we are going to pick it up and we are going to do 12. And since I know and I can't trust you all that you know class 11, we are going to start from class 11 itself. Okay. So differentiation or derivative. What does it help us to? I'm going to study each of the topics separately again. Differentiation or derivative for a commerce student is one of the most important topics. Later on, if you want to do economics honors or something, majority of the concept uses differentiations and integrations. So in differentiation, we talk about the turning points, how the single 1 point or 2 point change the entire scenario. Earlier it was increasing and suddenly something happened. There was a fire in the market, or there was a fire in the manufacturing plant, or there was a launch of a new product, or a new company stepped in, or say a GST rates change. Something happened and it changed the entire dynamics, right? So that is your turning point. Yes. Second, maximum value, minimum value. As I said, point B was the point of maxima, minima. Where do you get your maximum and minimum values? Increasing and decreasing. When are the values increasing? Which portion you were in your growing stage? Where did you started declining? All those things. Marginal values. That's there already in economic marginal cost, change in revenue, turning points, break-even points. All those things are also studied using differentiation. Then we have the topic integration. We usually have lesser integration applications. The first one we will use is area. How do we use integration to find the area? And back tracing the differentiation. We'll come to that. This is what the chapter entails. We are going to study differentiation and integration. We are not going to study continuity. Clear?
Yes, ma'am. Yes, ma'am.
Now, to study differentiation, there are two things that I need. Okay. First, today we are only going to see, I can't teach you directly sums. That's not who I am. I need to tell you how, why, from where did I get those things. I need to explain those. I can't be a teacher who tells you that this is the formula, apply here. In this case, apply this. I can't work that way. We'll come to that. I'll also teach you that. But I need to tell you how and where. Okay. So now, in order to understand what I'm about to teach you for differentiation or derivative, you need to know two things. One is limit. So, how we write? Limit x tends to a f of x, or LT x tends to a f of x. For example, limit x tends to 3, 5x minus 7. So, if the value of x approaches 3, then the value of the function 5x minus 7 will go to which portion, which value, which real number is what it helps us to find. So, in limit, we can directly put this value 5 into 3 minus 7, 15 minus 7, 8, because it's not getting undefined. Sometimes it will. X tends to 2, x square minus 4, x minus 2. Can I directly put the value x equal to 2 here? No, because it will make my denominator 0. It will make my function undefined. So what we do is we do a little simplification first. X plus 2, x minus 2. It gets cancelled. 2 plus 2, 4. This is how we do it. But what do we mean? Suppose if this is x equal to 2 and I'm approaching 2. I am approaching 2. So what do I mean by that thing? If from here I am approaching 2, that means x tends to 2 minus. 2 minus means from the portion where the values are smaller than 2. Earlier 1.5, then the value went 1.6, then it went 1.7, then 1.8, 1.9, 1.9, and it's too slowly and steadily moved towards 2. At that moment, where will your function go? Suppose it goes to 5. And when I'm approaching from the right hand side, x tends to 2 plus, I'm approaching from here 2.5, 2.4, 2.3, 2.2, 2.1, and so on. At that moment, where will the function go? If it goes to again 5, that means left hand limit x tends to 2 minus in the RHL, right hand limit x tends to 2 plus. If these two are giving you the same value, they both are telling me that you have reached the point 5, then limit exists. Limit exists. Otherwise, no. Limit exists, otherwise no. So x tends to 2 means the value of x is nearing to. The difference between x and 2 is slowly and slowly decreasing. This is what we mean by the word limit. This is as much as I from you. Is it clear?
Yes, yes, ma'am.
And the second thing what I'll need in calculus, we need straight line concept a lot. Straight line. So, if this is your graph, when we draw a line, this is considered, this is the x-axis, that's your baseline. We consider this to be the reference line. So, whenever we are drawing a line, suppose this is the line, line 1, or this is your line 2, or this is your line 3, right? So, whenever you have a line, right, every single time we ask, how much is it inclined with the x-axis? So now when I say x-axis, it can be on the right side or on the left side. So we are always talking about this portion to be your reference line side, positive side of x-axis. We move anti-clockwise. So what is the angle of inclination of a line with the positive direction of x-axis from in the anti-clockwise direction? So from here, this line L1 forms an angle theta 1. This is known as angle of inclination. Okay. For L2, I'll move from here. This is theta 2. This is angle of inclination. In L3, it doesn't even intersect the axis. So here the angle will be 0 degree, right? So every single line, no matter if it's parallel, perpendicular, or intersecting, it will always have an angle of inclination. The angle that it makes with the positive side of the x-axis when it is counted anti-clockwise. And we say the ratio. See, trigo is trigonometric ratios. When I say tan theta, I mean ratio, right? Perpendicular by base. So, slope of a line is tan theta. Slope of a line is tan theta. That's a ratio, right? But we are not good with the trigo part. So, what does it say? This is the line. There are 2 points here, x1, y1 and x2, y2. So again, the slope of a line that is denoted by small m can also be calculated using the coordinates of the line. That is difference of y by difference of x, coordinates of the point that lies on the line, which is what we will be using. So m is y2 minus y1 upon x2 minus x1. Difference of y by difference of x. You can also write y1 minus y2 by x1 minus x2. What is slope of a line? It's a unique ratio that is allotted to each and every line. So we can calculate that ratio value using the angle also, tan theta. We can also calculate that ratio value using the coordinates on the line. The points on the line, you can take any two random points, doesn't matter, right? So the slope is a unique ratio and it's the soul for a line. We need this point. Now, coming back. Now, if I have x-axis, there are 2 points on x-axis, say 1, 0 and 2, 0. If I want to calculate this line, slope of x-axis, difference of y upon difference of x, 0 by 1, that is 0. So we need to remember that slope of x-axis is 0. Slope of x-axis is 0. So to understand this portion, what I'm about to teach, I only need this value. First, what is m? M is the slope. Slope is a ratio. How do we calculate? y2 minus y1 upon x2 minus x1. What is the slope of x-axis? It is 0. What is the slope of x-axis? It is 0. Clear?
Yes, mom.
Yes, ma'am. Okay. Now we come to the actual chapter. We are going to start differentiation or derivative. Okay. So what do I want? See, the actual sums part is completely different. We'll come to that. And what I'm about to start, the explanation part, it will be useful when I'm doing AOD, application portion. Straight from these concepts, I'll pick up all five. So I'll tell you, see, I told you that, that's why this chapter. I told you that, that's why this chapter. So what I'm about to teach you today is more important for the application part than for the derivative chapter itself. Because in derivative, we are going to learn plus minus, like the technique, how to do the sum. But the actual conceptual question will come in application. So what I'm about to start now, the explanation part is more important for AOD. So what is differentiation or what is derivative? If I ask you a question, which which geometrical figure you are most comfortable with? A line, a circle, a triangle, a quadrilateral, a parabola, hyperbola, an ellipse. There are so many. Which thing you understand the most or you know most about? Or you have studied the most about?
Line.
Line. Agree? We are all comfortable more with that an entire chapter of straight line, right? So even if I don't, I can read it because every line has same properties. It's not that the shape can change. No. It's the same way. That's wrong. So what's the problem? If you give me any random, why are we studying calculus? Because a random function has a random graph, which I don't know. That's the problem. So now coming from that problem, you give me a function, you give me a supply equation or a sales report or a sales equation. I want to know what happened or what will happen in a particular year at a particular point. So randomly, I want to study a point on the graph, or study a point on the function. That's not possible for me. Why? Because I don't even know how the function looks like. Whether that point is going to be at the top, whether that point is going to be in the increasing stage of the curve, whether that point will be in the decreasing stage of the graph. How should I judge that point? Whether the sale in that year is good or not, whether the output in that year is good or not. How will I know if I don't even know the actual function? How does the function look like? Right? So what we do is, whenever we want to study the point, any random point in the graph, we try to relate it. We try to use straight line for it. If I can do what? If I can relate that point on the graph, any graph, it looks like no matter what. If I can relate that point on the graph with a straight line, with a straight line, I can find a relation. I can say that this straight line is a family member of this particular point. Then what will I do is all the information I'll extract from the straight line and use it for that plan. Why is that so? Because I know the straight line. I know how to calculate slope. We later on also learn how to calculate equations, how to calculate values. We'll know everything about the straight line. So we are more accustomed to knowing about straight line, to dealing with straight line, right? So what I want to know is whether every point on the function can be studied with a straight line or not. If yes, then I'll say that derivative exists. If no, I'll say derivative does not exist. They're not flexible. Again, if I can study any point on the function or the graph of a function with the help of a straight line, I'll say the derivative exists. And if I can't study with the help of a straight line, I'll say that it does not. So now let's see. Don't write. Suppose I have this function. This is point A and this is point B. You told me that you use a straight line, right? Fine. Let's use the straight line. Let's use this straight line. Okay. So what I wanted is to study the point A. I wanted a straight line. I draw a straight line. Can I use this line to study the properties of the point A? I'll say no. Why is that? Because if I'm taking this line will have a fixed slope, this line will have a fixed angle, this line will have a fixed equation. Everything will be only one, unique. So those things will be associated with the point A, right? Same thing will also be associated with the point B also. Yes or no? Because this particular line cuts the curve at 2 points, A and B. So whatever you extract from the line has to be given same to both A and B. Yes or no?
Yes, mom.
Yes, ma'am. Look at the graph. Does point A and B will share the same property? Can they share the same property?
No, mom.
Oh, we can see B is at a very, very below stage. It's not even started growing properly, and A is at the peak. A is at the top. A is at the maximum level. So can A and B have the same property? No. So can I take a line which cuts the curve at 2 points? No. Because if it does, then both the points will share the same property. And can it happen? No, it can't happen. So I cannot take such a line which cuts my curve at more than that point. If I want to study the point A with the help of a straight line, what type of a line I should have? A line which cuts my curve only at A. It does not cut at any other point. If it cuts at any other point, like in this example, then they will share the same property, but that cannot happen. So what kind of a line should I take for the point A? A line that cuts the curve at exactly 1 point.
Yes, mom.
If a line exists which cuts the point A at exactly 1 point, touches A, then I will use that line, because then whatever I get from that line will solely be for the point A. What is known? What do we say such a line which cuts the curve at exactly one point?
Tangent.
Tangent. So I don't want a random line. I want a tangent at A. Yes or no?
Yes, Yes, mom. Mom. Yes, mom.
My graph is this. This is modulus graph. This is point A. I want to study point A. So what did we say? What type of a line should I use?
Tangent. Tangent.
Tangent. What is a tangent? What is a tangent?
It touches the curve or only on one point.
Exactly one point, right? So is this a tangent T1?
Yes. Yes,
Yes.
mom.
So whatever angles are here, whatever properties are here, I'll take it to A. Is this a tangent?
Yes, Yes, mom. Mom.
Yes. So again, T2 will also have its property. Does T1 and T2 have same properties? Definitely not. T1 is a horizontal line, T2 is a slanting line. They will not even have the same angle of inclination. So let alone slope is different, equation is different, everything will be different. So if T1 and T2 are both tangents and we deduce that we need to use tangents to say the properties of a line, then how can I have these two different tangents? Because in this case, there will be a contradiction. Whether A should take here T1 or whether A should here T2, there will be a problem, right? So only tangent is not the necessary thing, because if more than one tangent is drawn, then there will be contradiction about which tangent to be included, which tangent should be used to deduce the property. Yes or no?
Yes, mom. Yes, mom.
Right?
Yes, mom.
So being making a tangent, drawing a tangent is not necessarily the only thing that we need. So can you tell me by what I explained, what do I actually want?
Mom, that both the lines must have the same properties. A
And when will
particular function.
if they are the same line? Otherwise, they will never have. Can me and you have the same properties? We are two different persons. No. It can only happen if we are talking about the same person. I may give the name, suppose you know me as Varsha Sharma. Earlier, my name was Varsha Sharma. Now it's Varsha Agarwal. So if one person says Varsha Sharma and another says Varsha Agarwal, that's the same individual, same property. Why? Because it's the same person. So if you are saying that T1 and T2 should have the same property, that means T1 and T2 should be the same tangent. That means at the point A, I should not have more than one tangent. How many tangents should be possible to draw there? Only one. If that is the case, for example, if this is the curve and I take this particular tangent. So, and if we can say that, yes, only this particular tangent can be drawn, I'm saying that. So, I will use whatever properties this T tells me for the point capital A. Understood?
Yes, mom. Yes, Yes, mom.
When will I be able to study a point with the help of a straight line? If a unique tangent can be drawn at that particular point. Yes or no?
Yes, mom.
And
Yes,
if I
ma'am.
can use a line to study the point, then I say that the function is differentiable. So I'm redefining my definition. When will I say that a function is differentiable at A? When will I say that the derivative of the function exists at the point A? If I can draw a unique tangent at the point A. If a unique tangent can be drawn at the point A, then we say that the function is differentiable. The derivative of the function exists at that point. Do you all understand?
Yes, mom. Yes, mom.
If the
Yes,
case
ma'am.
is that I can't draw the tangent, it is not differentiable. If the case is I can draw more than one tangent, the function is not differentiable. It has to be exactly one, neither less nor more. So if at any given point on the function, any given point on a curve, on a graph, I can draw a unique tangent, then that particular point will be differentiable. The derivative is going to exist for that point. Clear?
Yes, mom. Yes, mom.
A function fx is said to be differentiable, or the derivative of a function exists at A if and only if a unique tangent can be drawn at the point A on the curve. Is it clear?
Yes, ma'am. Yes, ma'am.
Written?
Ma'am, just a second.
Yes, ma'am. 1 second.
Yes, ma'am.
Everybody done?
Yes, ma'am.
Yes,
Okay. Now, as I said, we can't draw the graph. I can't draw tangents and tangents to the graph and see whether only one tangent can be drawn or more tangents can be drawn. What we need is we need an algebraic formula. So let's derive that. How will I get it? So I'm showing you the derivation. Then I'll reduce a formula. And then we will use only the formula to say yes or no. Okay, but how did I reach that? How does it ensures, how does that formula ensures what I just explained? That if this formula is happening, if this sum happens, then I can conclude that graphically there is only one tangent. How does the connection fit? That is what I'm trying to explain now. So, okay, tell me one thing. If I have a function this and I put x equal to 3, what do you get in return?
Then,
10.
What do we say 10 is? F of 3?
yes, ma'am.
And when I take the coordinate, what will I write?
3, 10.
So when I'm writing the coordinate, usually we write x comma y. Right now, what did I write? X comma f of x.
Yes, ma'am.
So y and fx are same thing. Y and fx are same thing. Y and fx are same thing. So x coordinate is horizontal one. Y coordinate tells me the height. So y coordinate I say or I say f of x. It means the same thing.
Yes, ma'am.
Okay. So let's start. So what I want to see is whether this is my graph. I have a function. I want to study point. See, right now you will say, I can see now there is only one tangent to be possible. And you won't have the graph. Right now I have drawn the graph for your understanding. But every time you won't have the graph, you need to do it algebraically. So I'm taking the help of the graph to deduce the formula so that later on you'll only use the formula and go on doing the sums. So my objective is to say that at the point A, there is only one tangent, right? If I can prove that at point A, there is a unique tangent, then I can declare that yes, the derivative of the function exists at A or the function is differentiable at the point A. Clear?
Yes, ma'am. Yes, ma'am.
Okay. So let the coordinate of A be at A, x coordinate. So x coordinate is what? The length. This is A. What will be the y coordinate then? If the graph is of the
F of A.
function f, very good. This will be f of A. Okay. Let's take a point from here, B. So point B will have its x coordinate smaller than A.
Yes, ma'am.
This is still only here. So if this gap is h, so coordinate of x coordinate of B will be A minus h.
Yes, ma'am.
What will be the y
Yes, ma'am.
coordinate?
F of A minus H.
Very good. Till here, any doubt?
No, ma'am.
No, ma'am.
Everybody?
No, ma'am.
Now I'm gonna join A and B. So if I join the 2 points A and B, what do I get? A
A
line?
straight line.
A
Slope.
line. Okay. So can you tell me what will be the slope of line AB? What was slope formula?
Y2 minus Y1 by X2 minus X1.
2 minus
So
x1.
from here, you tell me what will be the slope? The y coordinate difference minus the x coordinate difference. Do you agree?
Yes,
Yes,
ma'am.
ma'am.
Yes,
All of
ma'am.
you agree? So I can subtract in any order. So f of a minus h minus f of a, x coordinate a minus h minus a. Any doubt?
No, ma'am.
No, ma'am.
y2 minus y1 upon x2 minus x1. So f of a minus h minus f of a divided by minus h. Till here, everybody clear?
Yes, ma'am.
Yes, ma'am.
Now, what do I want is the gap between A and B. I'm trying to reduce. The gap between A and B, I'm trying to reduce. So this is the existing value of H. I'm making it smaller. So B comes here. This is the line. At that moment, whatever is the value of H will give the slope of the line AB from here.
Yes, ma'am.
Okay. Let's reduce the value of H even more. The point goes nearer to A. I reduce the value of H even more. The point goes even near to it. So if I say that H tends to 0, if I say H tends to 0, if I say H tends to 0, right? That means the difference between A and B is almost negligible. B is almost here.
Yes, ma'am.
Yes, ma'am.
And now when I join A and B, and then I look from my naked eye, how does it look? If I take this line, how does it look? If I extend this line, how does it look? This was B. The line that I joined AB, and if I extend, it looks like a
Tangent.
tangent. So when H is almost 0, then line AB becomes tangent AB. Do
Yes,
you all
ma'am.
agree?
Yes, ma'am.
Yes, ma'am.
And under this condition, when H is about to be 0, this will be the slope of what? The tangent AB.
Yes, ma'am.
So limit H tends to 0. Limit means I'm approaching to a state where H is almost 0. At that moment, this ratio will give me the slope of left tangent AB. Left because the tangent is on the left side. Is it okay?
Yes, ma'am.
Yes, ma'am.
Everybody okay? So what we have done is approaching the value of H as it reduces, the line AB does not remain a normal ordinary line. It, when extended, looks like a tangent. So the slope that we calculated is no longer the slope of the line. It has now become the slope of the tangent, right? So now if you understand, suppose this limit does not exist. If we are calculating the limit and the denominator became 0, so we will say that the limit does not exist. If the limit does not exist, so the slope does not exist. If slope does not exist, then tangent does not exist. If tangent does not exist, then there is no derivative. Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Right? So if I want my tangent to exist, this slope should have a value. It should exist.
Yes, ma'am.
Yes, ma'am.
Okay. Second, suppose this exists. And if I can find another tangent, even then I will say that the function is not differentiable,
Yes, ma'am.
right? So let us see, can I find another tangent? Is it possible for me to find another tangent? So I take a point here C. So the x coordinate of C will be more than that of A.
Yes, ma'am.
So I'm keeping it at the similar distance. C. What will be the coordinate?
A
X
plus
coordinate
H, comma,
A
F, comma,
A
A plus H.
f of A plus H. Again, if I join it, I will get a line AC. What will be the slope of line AC?
f of A plus H minus f of A by A plus H minus A.
Perfect. So f of A plus H minus f of A divided by H. Again, what I'm going to do is, I'm going to reduce the value of H. So slowly C will be nearing to A. Slowly the value of C will approach A. And when the value of H is almost 0 here, and I join A and C, how will it look like?
Like a tangent.
Like a tangent. So when H is almost 0, line AC will look like a tangent. And at that moment, this will give me the slope of the tangent. So f of A plus H minus f of A by H, it was originally the slope of the line AC. But if I now put a condition that H is almost 0, it now becomes the slope of tangent AC. The tangent is drawn on which side? The right side. So this has become the slope of right tangent AC. Is it understood?
Yes.
Yes, ma'am.
Yes, ma'am.
So suppose it happens, I calculate the left side value, it gives me 2. I calculate the right hand side value, it gives me minus 5. It's similar to this situation. This has slope 2 and this line, it's at the same point. It has slope minus 5. So if both the tangents on the left and right are giving me two different slope values, that means how many lines are there? There are two different lines, there are two different tangents, like.
Yes, ma'am.
Yes,
So if
ma'am.
the left tangent and the right tangents have different slope value, that means there are two different lines, there are two different tangents. So what will I conclude?
It is not
It is
differentiable.
not differentiable.
Understood? But if they both give me the value 2, that means what? If they both give me the value 2, that means this was A, this was B, this was C. So I was calling this side portion as AB, I was calling this side portion as AC. Basically, it is the same line BAC. So if they give me the same value, that means you're talking about the same line. So how many tangent? One tangent, unique tangent. So what will I conclude?
It is differentiable.
It is differentiable, right? So this portion, the left hand wala, is known as LHD, left hand derivative. So what we do is, whichever point you want to test, for that point, we calculate this value, LHD formula. For the right hand side, we say RHD, right hand derivative. The formula is limit h tends to 0, f of A plus H minus f of A by H. We calculate this. If LHD and RHD are not same, then what do we conclude?
It is not
It's
differentiable.
not differentiable.
Then if the function is not differentiable at x equal A, and if LHD and RHD gives you the same value, say 5, for example, then f is differentiable at x equal to A. Did you understand this?
Yes, ma'am.
Yes, ma'am.
Yes,
So in
ma'am.
class 11, you were given these two formulas. That if you want to test at 3, instead of A, put 3, calculate. If both the limits give you the same answer, you say that, yeah, it is differentiable. And if they give you a different answer, you say, no, it is not differentiable. Did you understand the logic behind it?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
Both of them gives me the value 5. What is 5 actually? Suppose LHD gives me the answer 5. What is 5? Graphically, what does it represent? 5?
ma'am, the slope of the line.
Slope of which line?
Ma'am, of the tangent.
Of the tangent, of that unique tangent. Yes or no? And
Yes,
that
ma'am.
5 is basically the answer of the derivative also. So every single time when we calculate derivative, what are we actually calculating? We are calculating the slope of that unique tangent. Yes?
Yes, ma'am.
Yes, ma'am.
And that's why in differentiation, we have another topic, tangent normal. Reason? Because derivative gives you what? Slope of tangent. Derivative is nothing but the slope of tangent. If the answer for derivative is 0, then the slope of the tangent is 0. If the answer of the derivative is 7, the slope of that unique tangent is 7. Yes or no?
Yes, ma'am.
Everybody understood?
Yes, ma'am.
Yes.
Now, how do we write? Suppose the derivative exists. I'll say f dash dash represent that I have differentiated it. At which point A? And what did I get? I got 5. This is how we write.
Okay, ma'am.
So, question. Function is x squared. Check if f of x is differentiable at x equal 3 or not. So instead of x equal a, I have given you x equal 3. That means the value of a is 3.
Yes, ma'am.
Yes, ma'am.
Okay. So I need to check. That means I need to calculate LHD. I need to calculate RHD. If they both give me the same value, then yes, it is differentiable. Otherwise, no. Do you agree with the plan?
Yes, ma'am.
Yes, ma'am.
So here A is 3. First, let us write the formula of LHD. Limit h tends to 0. F of A minus h minus f of A y minus h. Instead of A, let us put 3. F of 3 minus h minus f of 3 y minus h. So the function is x squared. What will be f of 3?
9, ma'am.
9.
3 square 9. What will be f of y? Just go with the flow. You don't need it. I'm just asking. What is f of y?
F of x.
0.
No, f of x is x squared. So f of a. If I would have asked you f of a, what will f of a be? A square.
Yes, ma'am.
F of b.
B square.
F of 1 plus b.
1 plus b whole square.
Plus b the whole square.
F of h.
F of, sorry, h
X
the whole
square.
square.
F of 3 minus h.
3
3
minus
minus h the whole square.
The whole square.
So instead of f of 3 minus h, we will write 3 minus h whole square because the function was given that way. Minus, what is f of 3?
9.
9.
9. Right now, can I put h equal to 0?
No, ma'am.
Because the denominator is 0 right now, right? Limit h tends to 0. Let's calculate. 3 square minus twice ab plus b square minus 9. 9 gets cancelled. Minus 6h plus h square by minus h. Taking h common, minus 6 plus h minus h. H gets cancelled. Minus 6 plus h minus 1. Now can I put h equal to 0?
Yes, ma'am.
Minus 6 upon minus 1. Answer is 6 for the left side. So the tangent that can be drawn on the left hand side is 6. So we have deduced that one tangent is definitely possible. Yes?
Yes, ma'am.
Yes, ma'am.
Now we'll calculate RHT. Limit h tends to 0. F of a plus h minus f of a by h. F of 3 plus h minus f of 3 by h. What will be f of 3 plus h?
3 plus h.
Plus
The
h
whole square.
whole square.
Minus 3 square upon h. So 9 plus 6h plus h square minus 9 upon h. 9 gone. 6h plus h square by h. Taking h common and cancelling 6 plus h. So if I put h equal to 0, we get 6. So both the left hand side and the right hand side are same.
Yes, ma'am.
Therefore, f is differentiable at which point?
X is equal to 3.
And answer f dash 3 will be 6. Clear?
Yes, ma'am.
So if I
Yes,
have
ma'am.
to check, I need to calculate both LHT and RHT and then see if it's same, then yes, otherwise no. But if I now tell you, just find the derivative. If I tell you, find the derivative of f of x equal x cube at x equal 2. I've told you find. If I'm telling you to find, that means the value exists.
Yes, ma'am.
If
Yes,
the
ma'am.
value exists, then LHT and RHT are going to give you the same value.
Yes, ma'am.
Yes,
So why
ma'am.
to do both? We can do only one and we'll have our answer. Right?
Yes,
Yes,
ma'am.
ma'am.
Both LHT and RHT gives the same answer, then we can only calculate one and find the value. And conveniently, it's said that we should always do RHT. Just a convenience. It's not a logic or there's no explanation. It's just written that always do RHT. Even if you would have done LHT, you will get the same answer.
Yes, ma'am.
Yes, ma'am.
And using limit, finding derivative from limit is known as first principle method. Is known as first principle. So if they tell us use first principle, only then we use this. Otherwise, the formula that I'll teach later on is what we are supposed to do. So I want to calculate the value of derivative, that is f dash, at the point 2. So we will be using RHT. Limit h tends to 0, f of a plus h minus f of a by h. Calculate. Tell me what's the answer. Done?
Just a second, ma'am. Ma'am, is it -8?
Sorry?
-8?
No. Okay. Limit h tends to 0. What is f of 2 plus h?
2 plus h the whole cube.
Very good. F of 2 will be 2 cube upon h. Let's open whole cube formula. A cube plus 3a square b plus 3ab square plus b cube. 8 gets cancelled. Let's take h common. 4 3s are 12, 3 2s are 6h plus h square. H gets cancelled. Okay, now can I put h equal to 0?
Yes, ma'am.
So the answer would be 12.
Yes, ma'am.
Clear?
Yes, ma'am.
Yes, ma'am.
So this was specifically one point. Okay. So as I said, this is using limit. There are also formulas. How do we get those formulas? Suppose I tell you, find the derivative of f of x equal x square. Did I give you a point at which you need to find?
No, ma'am.
No. If I don't give you a point, you find at x. You find the value at x. So instead of a, we will be putting x and we'll find the value at a random variable. So f dash x limit h tends to 0, f of x plus h minus f of x by h. Is it understood?
Yes, ma'am.
If a
Yeah.
point is not mentioned, we find the value at a random variable x. Complete. Tell me the answer. What will be f of x plus h?
Ma'am, is the answer 2x?
Yeah. This would be x plus h whole square minus f of x will be x square upon h. Let's open whole square. X square plus 2xh plus h square minus x square upon h. X square gets cancelled. Taking h common, 2x plus h upon h. So limit h tends to 0, 2x plus h. We can put h equal to 0, so it is 2x.
Yes, ma'am.
So this is a formula. The differentiation of x square is 2x. The differentiation of x square is 2x. So if I would have then said, hence, find f dash 1 plus f dash 3. Hence, find f dash 1 plus f dash 3. So what we have calculated is f dash x. Now, to calculate f dash 1, what are we supposed to do? We're supposed to only put x equal to 1 directly here. So 2 into 1, 2. To calculate f dash 3, we can put at x equal to 3 in this particular answer that we have deduced. So we will get 2 into 3, that is 6.
Yes, ma'am.
Now,
Yes, ma'am.
f dash 1 plus f dash 3 would be 2 plus 6, that is 8. Clear?
Yes, ma'am.
Yes, ma'am.
So what do we learn here? See, in this entire topic, when we're discussing how to differentiate and how to we actually calculate the derivative, did we ever use graph? No, we just use an algebraic limit property, right? We use the concept of limit, we use plus minus and algebra to find the value. And how do we actually know that finding this sustains and finding this declares that yes, it is differentiable? Because of this derivation. Because of this derivation, the concept that we find the tangent, find the slope of the tangent that is drawn on this side, we find the slope of the tangent that is drawn on this side. If they are same, then it means the same tangent, so the function will be differentiable. So what does LHT and RHT actually tells us? It tells us the value of the slope of the tangent drawn. And when the slopes match, we say that a unique tangent is drawn. And when a unique tangent is drawn at a point, we say that the derivative exists at that point. Am I clear?
Yes,
Yes,
ma'am.
ma'am.
So using this function, using this formula LHT, RHT, we can derive every single formula. In class 11, you had limits for every single term. You had formulas, you have logarithmic formulas, you had exponential formulas. Every single, using those limit definitions and using this derivative LHT, RHT definition, we can deduce all the formulas. And as I said, first principle has to be specifically mentioned. And I don't think it ever comes in 12. I've seen only once. What actually comes are formulas. See, we are in 11. We are going to be in 11 for quite some time. Okay. So what are the formulas that we are actually going to use? Okay. The symbol that we used first. Sorry. Symbols. What we are going to differentiate are functions. Function is sometimes written by y, or it is written as f of x. The derivative, we are studying first order. First order. First order means we am differentiating the function for the first time. So I can write f dash x, which I just drew. But the symbol of differentiation is d by dx. This is symbol of differentiation. The d in the numerator means differentiate. The dx in the denominator means that the function should consider the variable as x. If it is x square plus 1, the variable is x. That's why dx. If it would have been y square plus 1, I would have written dy. So the variable that is used in the function is what we write in the denominator. So we write this before the function that we want to differentiate. So I can write d by dx of y, that is dy by dx, or d by dx of fx, which is also written as f dash x. These three are the symbols of differentiation. So to whichever function, before whichever function we write d by dx, that means I'm trying to differentiate that function. Yes?
Yes, ma'am.
Yes,
Formulas. First, d by dx of constant. Now, we need to first understand what is constant. Okay. So constant is what? All numbers are constant. Even letters, anyone outside x and even y, because we use y as a name, right, for the function. All the variables except for the one that is written in the denominator, which are in our case is x and y. Except for these two letters, all the other letters are considered to be constant. A square is a constant. Log b is a constant. T cube is a constant. Any letter besides x, which is written in the denominator, and y are written to be constants. Yes, numbers are obviously constants. So differentiation of constant is always 0. Because when I'm going to do y2 minus y1, it will be 2 minus 2, 3 minus 3, 5 minus 5, constant minus constant. It will always give you 0. So differentiation of log 100. Since there is no x, answer is 0. Differentiation of a plus b whole square. There is no x, answer is 0. Differentiation of any expression where there is no x, no variable, answer is 0.
Yes, ma'am.
Okay, ma'am.
Second, differentiation of variable, the one that you have considered, to the power constant, any number, any constant, any constant. What are constant? Anything is sides x and y. So x power n would be n x power n minus 1. It reduces. So if I want differentiation of x square, x raised to the power constant. So 2x power 2 minus 1, that is 1. So 2x, we just derived this. So the differentiation of x square was 2x. So differentiation of x power n is n x power n minus 1. Differentiation of x. X means x power 1. 1x power 0, that is 1. What will be differentiation of x power 5?
5x to the power.
5x power.
5x square.
So from here, we need to memorize a few. Differentiation of x will be 1. Differentiation of x square will be 2x. Differentiation of, okay. How will I calculate root x now? Root x means the power is
1 by 2.
So this will be 1 by 2 x power 1 by 2 minus 1 n x power n minus 1. 1 by 2 x power minus 1 by 2. Since the power is negative, we take it to the denominator plus half. So this becomes 1 by 2 root x. So this is something we use very frequently. So memorize. Differentiation of root x is 1 by 2 root x. Differentiation of root x is 1 by 2 root x. Clear?
Yes, ma'am.
Yes, ma'am.
Differentiation of constant,
0.
0. Differentiation of x square,
nx power n minus 1.
x square,
2x.
2x, x cubed,
3x square.
X square.
x,
1.
1, root x,
1 by 2 root x.
1 by 2 root x. And the formula differentiation of x power n will be n x
And
power
x
n.
power n minus 1.
Now, if you say, I want to find the differentiation of 1 upon x power 10, how should I do it?
X to the power minus 10.
Numerator.
We first bring it to the numerator, x power minus 10. So now this looks like x power n.
Yes,
So
ma'am.
n
Yes, ma'am.
x power n
Ma'am.
minus 1.
Yes.
So minus 10 divided by x power 11.
Yes,
ma'am.
ma'am.
So I have made another formula. This is my doing. 1 upon x power n. If the variable is in the denominator, you can do the same thing. Bring it to the numerator and then do it. The same that we just did. Or it would be the power comes down minus n and here it increases. So see 1 by x power 10 minus 10 by x power 10 plus 1, 11. It just can be done in one go. What will be the differentiation of 1 upon x square? Use this formula.
Minus
2 by x cube.
What will be the differentiation of 1 by x? Power is 1
Minus 1
by increase the power.
x square.
x
Square.
square.
Next. Understood till here?
Yes, ma'am.
Yes, ma'am.
What is the
Yes, ma'am.
differentiation of x power
Yes,
20?
ma'am.
20. X power 20.
20x to the power 19.
Power
X
19.
power 19. 1 by x power 20.
Minus 20
Minus 20 by x power 21.
Very good. Minus 20 upon x power 21. What is the differentiation of 20 power 20?
0.
0, because it's a constant. Clear?
Yes, ma'am.
ma'am.
Yes, ma'am.
Number 4. Differentiation of log x. Note, base of logarithm has to be e. Base of logarithm has to be e, 2.7. So if nothing is written, that means it is basic. So only when the base is e, I am allowed to differentiate. And the formula is 1 by x. So differentiation of log x will be 1 by x. If I would have written log x base 2, I could not do it directly. There has to be something. We will do it later on, but directly the formula application can't be done. So I can only write log x differentiation is 1 by x if the base is e. And if nothing is written in the base, it means that the base is e. Clear?
Yes, ma'am.
Yes, ma'am.
That's it. Differentiation of a power x. So earlier, the second one we did is x power 2, x power 5, x power 10, x raised to the power constant. Now I'm saying constant raised to the power x, 2 power x, 3 power x, 5 power x. Here, note, a has to be positive. So a power x, again we can derive, we have derived, done this in class 11. It would be a power x into log a. Example, differentiation of 2 power x. Differentiation of 2 power x. It would be 2 power x into log 2. Differentiation of 3 power x. 3 power x log 3. Differentiation of 12 power x. 12 power x log 12. Yes?
Yes, ma'am.
And 6. Differentiation of e power x. E power x is again constant. E is constant, so it's the same formula. It will be e power x log e. What is log e? Base is nothing, so base is also e. Since the numbers are same, it's 1. Value of log e is 1. So that's why the differentiation is ex. So differentiation of ex is ex. Differentiation of 6 power x is 6 power x log 6. Differentiation of log x, 1 by x. Differentiation of x power 6, 6x power 5. Differentiation of 1 by x power 6 minus 6 upon x power 7. Differentiation of 6 power 6.
0.
0.
Is it clear?
Yes, ma'am.
Yes, ma'am.
So preliminary will be using these 6 formulas. We are still in class 11. It will take some time to go through it. Everybody clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
That's it for today's session.